Hello, my lovely viewers. Welcome to EV TV. Today we have a very interesting question before us here. And the question reads, which of the following is not isoelectronic with neon? This is based on isoelectronic species. We have the options here. Option A is sodium ion, magnesium ion, aluminum ion, oxygen ion, and calcium ion. Before we go into solving the problem, feel free, if you know the answer, if you can guess the answer, just put it in the comment section as we go. Alright, first let us look at what is called isoelectronic species. Isoelectronic species are chemical species, be it neutral atom, cations, or anions, that have the same electronic configuration, but with different number of protons. Let me say that again. That isoelectronic species are chemical species, be it neutral atom, cations, or anions, that have the same number of electrons, or that have the same electronic configuration, but with different number of protons. And the question says we should look at one of the particles here that is not isoelectronic with neon. We know that neon has atomic number 10, and of course, if we write the electronic configuration, we have something like this: 1s2, 2s2, and 2p6. Remember, usually if you count the superscript, that is the number on top of the letter Z, it must always be equal to the number here, which is the atomic number. So which of these particles here, that whenever we write the configuration, it will have a configuration that is not the same as that of neon. Let us take it from the first one. We'll take option A, which is sodium ion. Okay, so we have sodium ion with atomic number 11. Now, sodium having a positive charge here simply implies that sodium atom have lost one electron. So instead of having 11 electrons, it will now be remaining 10 electrons. So let us write the configuration and see whether it will be the same as that of neon. Right? We have 1s2, 2s2, and 2p6. You can see 2 plus 2, 4, 4 plus 6, 10. Because originally there were 11 electrons, but one electron has been lost to form sodium ion. Alright, we go to option B, which is magnesium ion. Magnesium ion is Mg2 positive with atomic number 12. So, what does this imply? It implies that a magnesium atom have lost 2 electrons so that it becomes magnesium ion. So it will now remain 10 electrons. Now, if we write the configuration, it will conform to that of neon. So we take it this way: 1s2, 2s2, and 2p6. We go to the next option, aluminum ion. Aluminum is Al3 positive with atomic number 13, meaning that aluminum atom have lost 3 electrons to form the aluminum 3 positive ion. So if we write the configuration, it will still remain 10 electrons, which is 1s2, 2s2, and 2p6. Complete. Alright, we go to option D, which is oxide or oxygen ion. Oxygen ion, O2 negative, has atomic number 8. O2 negative here simply implies that oxygen has gained 2 electrons to form the +2 oxidation state here, meaning that there are now 10 electrons in oxygen ion. Okay, let us write the configuration: 1s2, 2s2, and 2p6. You can see all our configuration here usually the same number of electrons. Let us go to the next one, which is the last, calcium ion. Calcium has atomic number 20. So for you to see calcium carry 2 positive here, it simply means that calcium have lost 2 electrons out of 20 electrons, meaning that it is now going to remain 18 electrons. It is going to remain 18 electrons. So we'll write the configuration this way. Alright? 1s2, 2s2, 2p6, this is 10, 3s2, this is 12, and 3p6. So if we add all the numbers on top here, it must be equal to 18. It must be equal to 18 because 2 electrons have been lost out of 20 electrons. So if you look at all the configuration here, the one that is not the same configuration with that of neon is calcium ion. So the correct option is option E. The correct option is option E. So how many of you were able to guess it very, very right or very, very correct? So don't fail to put your question or your comments in the comment section. See you in the next video. Thank you. Bye bye for now.